According to the 451 Global Data Center Alliance, enterprises use only 56% of their data center capacity. According to the Uptime Institute, 34% of data center operators have experienced a severe outage or service degradation last year. Also, according to the Uptime Institute, rack densities will continue to increase. Let's take a closer look at this challenge by zooming into a typical change request on this data center timeline. This change request adds 3 IT racks to this data center. The racks are high density, relative to what the data center was designed to support. Can this request be accommodated quickly? How should the deployment be configured to meet performance expectations? Today, change requests are addressed by applying simple guidelines or best practices for allocating space, power, and cooling resources. In our example, these guidelines would likely produce this configuration. However, if we were nervous about environmental compliance, we might pick this configuration. Or, if we wanted to aggressively conserve resources, we might go with this one. But here's the problem. Today's data center management tools and techniques are blind to the performance impact of physical changes to the data center. One of these configurations is best, but we don't know which one. This is the cloud of uncertainty that hangs over the head of every data center operator and leads to service delivery delays, environmental risk, and inefficient use of data center resources. This is where the concept of a digital twin comes in. Digital twin is a virtual replica of the physical data center. It's made up of 2 parts: a 3D data model that reflects the data center's physical configuration, and a physics-based simulation capability that mimics the data center's physical response to operational changes. Let's return to the example and use Digital Twin to simulate the impact of this change. After running the simulation, Digital Twin reveals something that we didn't know before. Option 1 will fail compliance by overheating existing IT racks. Digital Twin's ability to mimic physical behavior helps to avoid this unexpected compliance disaster. It also reveals the cause of the compliance problem and provides the foresight needed to design a solution. A new cooling unit will eliminate this violation, but at an unexpectedly high cost, after accounting for the cost impact of the new cooling unit. Digital Twin predicts that option 2 will meet compliance without having to upgrade the infrastructure. But this option is costly because it will use 25% more space and 16% more airflow than option 1. Digital Twin predicts that option 3 will also meet compliance without an infrastructure upgrade. Now this is an unexpected result, because gut feel says that 20 kilowatt racks cannot be placed this close together without overheating. But it's a good result because this option will use 50% less space and 14% less airflow than option 2. To summarize, in terms of compliance, Digital Twin predicts that all 3 options will pass, although option 1 will require an infrastructure upgrade. In terms of costs, option 3 is the most resource efficient across the board and enables the fastest and easiest service delivery. By using Digital Twin, we can select this option with confidence, knowing that it will meet compliance and conserve the most capacity for use in the future. This example illustrates the significant impact Digital Twin can have on a single change request. Over the entire lifespan of the typical data center, Digital Twin has the potential to increase capacity utilization by over 34%, while completely eliminating environmental risk and speeding up service delivery time. Thank you for watching. For more information about Digital Twin, please visit futurefacilities.com.